Just
Okay.
want to thank everybody for joining us today. The Koolen-de Syndrome Foundation Natural History Study has been well underway for at least 6 months now. And as everyone knows, we have had lots of activity. We did a lot at the summit, and then Megan and Anna have really been working with families to be part of that natural history study, sign them up on the accounts, filling out all the surveys, and we really just thank everybody. We know the surveys. I know personally the surveys can be a little much, especially if you in particular, but we do really need that data that will really help us move forward and be clinical trial ready. So with all that, I will let Anna talk a little bit and pass it around.
Awesome. Thanks for the intro, Ashley. Yes, I second everything that Ashley has already said. I'm pumped at this turnout, this live turnout. This is incredible. There are a lot of thank yous that we owe to all of you because I'm sure many of you are quite tired of seeing emails from Megan and myself. But we are really grateful for your participation in this really important clinical trial readiness endeavor, which is generation of an international natural history study. We know that the demands are consistent and somewhat time consuming, but we're really grateful to you. So today I thought what we would do would be to start showing you some of the work that's coming out of all of the surveys and the natural history study research components. As many of you who were at the summit this past year will remember, we had no fewer than 5,000 different research opportunities going on all at the same time. So I know many of you were scurrying around from room to room, giving blood donations, nitric oxide donations, which required things up your nose, as well as getting an EEG done, which was probably not the first time for many of you, but is a really essential component to looking for biomarkers that can tell us whether clinical trials, which are coming up for KdVS, are beneficial or not for kids with KdVS. So I will stop rambling. What I would like to do for the next hour-ish is to have my friend Dr. Pini present a little bit of the preliminary work that we have done from the EEGs that were collected at our summit. He is certainly an expert in this area and has done this with several other rare disease groups. And so that's why we were so pumped to have him join us at the summit.
I
Then
don't like
if,
that so it's kind of troublemaker. Austin.
oh, I think someone's calling you a troublemaker, but I think somebody else was. But let's say they're calling you a troublemaker, Nicolo. Okay. So the second thing would be to give people maybe a couple questions and answer minutes. And then what I'd like to do is Megan and I are gonna do a live demonstration, which is always a horrible idea to do live, but we're gonna try it. And maybe use Elena. I see Elena's little doggy figure and Ashley as our guinea pig to show you guys how you can start linking your kids' electronic health records to your Matrix account, which is the online data collection portal we're using for all of our natural history data storage right now. And that's, I think, between those two-ish, three things, we will probably fill up our time. Also, if for whatever reason you don't want to ask a question, you can put it in the chat and I'll be the person who is the bad guy and read it if you want. Okay, anything else that I should say before I hand it over to Nicolo? Megan, thumbs up. Ashley, nod, chat. Okay, Nicolo, can you share your screen? We should always
Yes,
do
I
that.
will get that one started and then we can get going. Can you guys see the presentation?
Hold up. Yes.
Okay, perfect. Let me just presentation mode. Is it still fine?
Now it's perfect. Yes.
Okay,
Except for
great.
continue to share.
Alrighty. So thanks for the intro both Ashley and Anna. It's really a pleasure to be here and really appreciate the support that the foundation has provided in trying to get at the bottom, or at least trying to get a preliminary characterization, as Anna was describing, at the EEG data that we collected over the summer. So brief agenda. So the next I have about 20-ish slides, which some of you might think looks a little bit like a crash course for EEG. Full disclosure, I usually, get people to understand most of this over an entire semester. So we'll try to do this over, half an hour and see how that goes. And you can, again, I'm a troublemaker, so you can blame it on me if that gets to be too hard. But again, feel free to interrupt at any time, ask questions along the way. I'll try to monitor the chat as much as I can. And then we can, oops, already messing out this, and then we can, get going as we would like. So the first few slides is going to mostly talk a little bit more in depth about like we're interested about the brain and why the brain matters, and how and why we feel like the brain matters in neurodevelopmental conditions and specifically genetic condition. And then the second part of the presentation is going to be more diving into some examples on the data that were collected over the summer, what that means, what we've been able to extract from such data, and next steps. And here I think would be very beneficial to be hearing not just what I think would be beneficial in some of the conversation that I had with Megan and Ashley, but mostly broadly like what you guys have thought maybe along the way and how that relates to your population. So I usually start with this, which, I acknowledge is some sort of like silly slides to get started. I think we all know and understand why the brain is interesting and why we do care about the brain. I think, and as I'm sure most of you have read about it, but the brain is involved in many of the processes that regulate our body and physiological system. We know that the brain certainly plays a role during development, and both in terms of like shaping trajectory of development, but also development itself shapes the brain both from a structural and functional point of view. And what we know from prior literature is the fact that the brain really the brain again plays a critical role, and is the fact that different studies and different research teams have shown that there's differences in brain, again both structural and functional. We're looking at population or participants that have some different developmental conditions, as well have some different differences in their development more broadly. And so the goal of what we're trying to do here was to see whether or not in the KdVS population this is true, and not just like talking about differences, which it's something also I struggle in the sense that within population there might not be that many differences, but often we tend to talk about differences with respect to typical developing kids, which I think is an ill posed problem. But that being said, we're really trying to understand which features of the brain are important and why we would like to look at the brain in more in depth. And as Anna alluded to, many of you had prior experience, I'm sure, with EEG, and many of you have shown or have described to me what it means having prior experience with EEG. Most of you were familiar with clinical EEGs, which are usually, ordered by clinicians where there's some suspect delays or other developmental differences. But what we did at the summit was more to look at short bursts of EEG, meaning short period recording times, to try to understand if we were to look at more, let's say, in-depth and more quantitative measure of EEG, we can actually try and understand if the brain can tell us more about many different things, including trajectories of development. And so this work, as also Anna alluded to, is, fits into this broader idea or this broader goal of trying to look at brain-derived biomarkers. I'm sure many of you and a lot of you have heard about biomarkers in general. And here we're going to talk a little bit more about brain-derived biomarkers, meaning from the EEG that we have collected, are we then able to collect biomarkers, to extract biomarkers, which can tell us about what the brain is doing, and again, long-term trajectories development. And so in the current phase that we are right now, we are trying to collect this efficient pilot sample size for biomarker. This is what we have actually achieved, and we'll go more into the details of what that means over the summer. And we want to characterize the sample biomarkers, meaning can we actually derive biomarkers? Biomarkers can tell us a little bit about the brain and about development, and how that relates to other things of interest. So, for example, more in the area of what Anna's been doing. So, biomarkers, can they tell us about long-term behavior? And then once we have some initial evidence of this, we would like and this fits more into the realm of longitudinal assessment. So we would like to collect additional samples, see whether or not any of these biomarkers that we derive are staying stable across development, and validate what. And with validation, we mean whether or not is it true that the associations that, for example, we are detecting now are actually then stable across development, or whether there's changes along the way, with the ultimate goal of using such derived biomarkers, which again have been characterized, validated, and then probably hopefully replicated to be then used in clinical trials, and most broadly using the clinical trial in the sense of using them as marker or as indices to be able to evaluate whether any intervention is actually effective
Hey,
towards the
Nicolo,
goal. Yes.
you said it was okay to interrupt you, right?
Yeah, absolutely.
Ah, perfect. So can you give an example or two of an EEG being a biomarker in a different neurodevelopmental disorder? And also, can you comment on um, whether you can use EEGs as a biomarker even if the individual doesn't have clear epilepsy or clear seizures?
Absolutely. No, that is a great question. And I do see a question in the chat, so I can also address that one. So to your question, so for example, well, maybe let's start with the second question. See, definitely there's evidence of the fact that EEG biomarkers or the value of EEG goes well beyond just epilepsy. Of course, epilepsy is something that usually takes precedence or more attention with respect to other, just routine EEG by the nature of the fact that usually is a more acute conditions and often early during emergence, it has to be medically addressed right away. And so definitely a lot of research that you might see, talks about epilepsy. At the same time, there's of course a close association or a close connection between epilepsy and neurodevelopmental differences in the sense that many neurodevelopmental conditions are characterized by epilepsy. So definitely, there's literature there, but biomarkers are, useful well beyond epilepsy. So for example, and I'm trying to talk about this without, violating not too many NDAs, not that I signed too many, but so for example, there's, evidence in a neurodevelopmental condition in, which I think it might be ZBP1, but I might be wrong on this. Would basically the goal of the study, which is led by someone at Cornell, was to repurpose a currently available drug for treating the condition. And so specifically what this person was looking at was this specific frequency in the band, which is called delta. We'll go a little bit into the details of that for sure. And what this person was seeing is that by administering this drug, which again is utilized for something else, they were seeing decrease in delta because the condition was characterized by excessive delta burst. And so by repurposing this drug, they were able to decrease that activity, and in turn, that led to an improvement in a neurodevelopmental outcome. I think they were looking specifically at one or two domains of Bailey. So that's, would be one example. I hope,
Yep,
Anna,
yep.
that was
Yeah.
you guys are
Yeah.
talking about.
Great.
So, drag repurposing for sure. We're conducting, for example, other work that I'm sure many of you are familiar with ASOs in other conditions. And so we're tracking longitudinal brain differences, pre and post dose, hopefully with some more assessments. So those are some, examples of that. Then Donna has a question in the chat. Do you think neurofeedback, e.g. biofeedback to repeating intervention is a good trained tool? Is it helpful?
Can you, before you answer the
Yeah.
question, explain the question to me?
Or at least I'll try to explain the question the way
Okay.
I understood. And Donna, feel free to add to this. So I think if I understood this correctly, maybe this fits a little bit into the TMS work, so transcranial magnetic stimulation of the brain, I think, which, as far as I know, it has definitely become popular in the realm of depression, treatment for depression and or addiction. And there are also some evidence of this, but I do preliminary in other situations, but maybe I'm completely wrong. I think in order for us to be able to make any statement on this, or let me backtrack. So the reason why it has been shown to work treating depression and some specific forms of depression, it comes from the fact that we do actually know pretty well what the brain does and how the brain works when it comes to like depression, depressive symptoms, and all the kind of spectrum of that. I think here we're not able, or we're not yet at a point to know which specific areas of the brain are involved. I know there's might be some work on this for cerebral palsy, but that is more focus because it might talk a little bit more on the motor cortex function. But as far as I know, I am not fully aware of anything which is either FDA approved or clinically more widespread about neurofeedback, EEG biofeedback in any specific neurodevelopmental condition. But I can also be completely off. But Donna, you let me know if again I'm completely off. Okay. Yeah. ADHD I've heard that too. But again, I don't think it's yet FDA approved there. It's more at clinical trial stage, I think.
Interesting. All
Yeah,
right.
very interesting. Okay. So, alrighty. So this is something, we talked. Okay, perfect. Thanks, Donna, for clarifying that. This is something we kind of went over a little bit in the previous slide. So what you have seen, me and Megan and other people contributed to the meeting was mostly working on collecting EEG. And so what we EEG, if we don't want to go into the nitty-gritty of what the physics is beyond like putting a bunch of electrodes on the scalp and trying to get electrical activity, you can think about it as a bunch of squiggly line on the screen. And this is, a well-utilized, widespread tool for collecting non-invasive informations about the brain and specifically brain activity. The reason why we're interested in this again is non-invasive is definitely less burdensome than doing an MRI. It can not just be done during resting, but as we'll see in the next few slides, it can also be used and utilized by administer different tasks to different participants. And so depending on the population, this was part of the discussion that we had prior to having the meeting, was also trying to understand which of the different tasks would be helpful and interesting to ask you to participate to. Alrighty. So I know this animation is one that Anna particularly loves, so I
My
want to
favorite.
put it there. So you might be wondering, and if this is too much, we can also skip cycle a little bit because I know it never stops. So we start from
This might
those.
actually induce seizures on people watching.
Well, if that happens, just raise your hand or have someone to do that and we'll take care of you. So basically, you start from a bunch of squiggly lines, and what we're interested in understanding is how we can get some numbers out of those squiggly lines. And the easiest way that we usually think about extracting those extracting information from those squiggly lines is to move the signal from, again, those squiggly lines, which you can think about like, there's one data point at one particular time. Then the next instant of time, there's another one, so on and so forth. So those squiggly lines keep progressing, on the screen. But then you can imagine that one way to be able to, again, look at these waves is to extract the different frequencies that characterize these waves. So as shown here on this moving image, you have, for example, this little blue dot that has a small amplitude compared, for example, to the red one, which has the highest one. But as you can see, it's much, much faster in progressive on the screen. So you can think about, for example, the blue dot as one having not that much energy within the signal, but it actually has very high frequencies associated with it. And then on the another option is, for example, this, or another example is this red guy right here. You can see it's taller, so there's more energy associated with this specific frequency. But as you can see, the number of time or number of jumps within the same time frame that is shown here are much fewer. So there's more energy associated with this red guy, but definitely is slower in progressing on the screen. So that you can think about, again, moving from this squiggly line to all these different frequencies. We're not going to go into the maths of that, but trust me on this, in the sense that we're interested in looking at the organization of these different frequencies within the signal. All right, as Anna described or just alluded to earlier, we're not doing this alone, and I'm not gonna go over all the different, groups that we've been working with and all the funding that we've fortunately received. But just to say that we're not gonna have just your data alone, and we have the unique opportunities to be able to look this in an ecosystem where we can group conditions, for example, by by genetics, by underlying biological mechanism, by many different ways, just to again trying to get at a more comprehensive pictures than just like a one snapshot. And of course, the thing we're interested in today, and again, I'm very grateful for the support received and all your help along the way to trying to design this the best way possible, is to look at the data that we have collected in the summer. And so, just a brief recap. I see some familiar names, so I trust most of you will remember, but it has been a few months. So let's just go over this quickly. So in the summer, we did a couple of different things. Once to have participants to look at a resting state video. This was approximately duration 5 minutes. You remember participants, individual kids, young adults were sitting in front of the screen. There was this colorful, playful cartoon going on, and just sitting right there passively looking. The cartoon add sounds and everything, and so that's there's some debate whether or not people call it that resting state, and whether or not that is the most standard or well standardized way to do it. This is a definitely open debate in the field of neuroscience, and happy to hear your thoughts about that. But this is the best I think we have in 2026 now about looking at resting state. And we going back to, I guess, previous slide, is we do have now this collected over probably 500 or 600 kids with neurodevelopmental conditions, and as many control as the ones we have with neurodevelopmental conditions. So definitely, we have, we're going forward with this, and we feel strongly about it. And then the second part of this was the so-called auditory evoked potential. This was longer, and as we anticipate, we'll see a little bit of that in the next slide. Some individuals could only suffer this for only a few minutes. Some other were real champions and were able to get it through the entire paradigm. It just a combination of the fact that coming after the first 5 minutes and having going for 10 minutes was a lot to ask. But again, we're pretty successful. Going back to Anna's point about biomarkers. So what we're really interested in looking at here. So in resting state, the things that we are primarily focusing on is the distribution of frequencies in the EEG. So you'll see some pictures of that, and I'll try to educate you a little bit about how or what do we expect in more traditional more traditional scenarios, and how some of the kids that we have seen are showing some differences. And then in the auditory evoked potential, again, having listened to you with respect to seeing some or mentioning some differences in terms of attention, stimuli, perceptions, and all of that, we were interested in understanding how different stimuli were perceived by the brain and whether or not we could detect differences in such stimuli. So if you remember about this auditory evoked potential task, what we had was a sound that kept repeating over and over for most of the time, and then there was two different sounds. One was the deviant and one was the novel. So again, sounds which were different than the main one, but they kind of kept repeating when the actually repeating sounds were not present. And then the novel one, which were only played once throughout the recording. And so the idea here is to understand how the brain is able to understand the stimuli, and how's the response there.
Hmm.
Do you have a question, Anna?
I mean, how did you come up with this paradigm?
For the evoke both or
Yeah, just like, the 5 minutes of resting
okay.
state, 10 minutes of auditory stimulation.
Yeah, so well, so for the resting state, well, both, or let me say it this way. So they both had been used for like for many years in the fields of more like trying to understand more basic responses of the brain. So that work was primarily simply just like trying to understand how the brain processes sounds, how the brain processes like, videos, or processing like visual stimuli and all of that. And so there's evidence on the fact that there were differences in different conditions. I mean, less on genetic side of things.
Mhm.
Which prompted like me thinking about it. And then the other part of this is that um they're both these exact same ones are used in the HPCD study, which I put a little bit
Mhm.
thing
Mhm.
here, which is basically the largest ongoing study looking at brain behavior in the US right now. I'm involved for collecting, part of the EEG data and other wearable data that,
Yeah.
it's not topic here. And so what I was thinking was, if we really want to trying to get normative values or normative responses, we basically will have about 7,000 kids that have
Wow.
done this exact same thing
Yeah.
in the age range between 3 months to like 10 years.
Oh,
And
wow.
so,
Okay.
they will definitely be getting, comparable results in terms of like biomarkers and response. And the good
Yeah.
thing about HBCD, the data is publicly available. So anyone can actually get it and play around with it and extract things the way they like. So that's was part of the rationale, trying to make it a little bit more open science and have reference values. Because I mean, I guess to your point, there's definitely many of the same things have been done in previous core and populations, but all are were kind of like minor variation around the theme. And then if you look at two different studies, the ranges are not even comparable. So that's
Yeah.
what's kind of the rationale.
Okay.
Okay,
Cool.
great. So, okay, let's go into a little bit more on the data. So, this is a flow chart. So we start from like, at the very top, there's a summary of everyone that we saw, and then progressively moving from top to bottom, you can see like who was included, who was excluded, and the reason as to why some participants, are not in the let's so-called like final analysis. So we had 52 participants who agreed on participating to research. And again, big thank you for being willing to, to work with us on this and collect this very, very precious data. Zero participants did not tolerate the net, which is, a funny sciencey way of saying that everybody was able to put the net on. They were able to actually collect some data. We'll go into a little bit more about what they mean, some data, a little bit later on in the presentation. But this is to say that everybody was able to tolerate the net with different degrees of tolerance for the net itself. But this by itself is a pretty substantial achievement in the sense that we seeing that everybody was able, and especially with such large number, to be able to wear the net is pretty impressive, and definitely not true for many of the other developmental conditions I work with. So again, great. But again, it was a great partnership between our team and of course you guys. As I was mentioning, three participants could not complete the auditory task. This just comes from the fact that wearing the net for about 15 minutes is a lot to us sometimes. And, there were also many other things going on the same day. So, this is totally in the range of what we see. Actually, we usually see a lot, a lot more unsuccessful attempts at the auditory task. So that was great to see. And then here is a summary of all the final numbers that went into some of the next few slides. So 52, so 100% of everybody we saw were able to look at the baseline video data, so the resting state, and so we could get data out of it. 49, so it would be the 52 minus the 3 at some auditory data task, and then for 49 participants at both baseline video and auditory task data. Here is some more on the data quality. So you saw in the previous slides where we're saying that there were some EEG data for everybody. as you might imagine, and as I've experienced yourself firsthand, putting the net on doesn't necessarily mean that the entirety of the 5 minutes or the entirety of the 15 minutes would provide usable and good data. Of course, individuals, participants want to move, want to, do something else. Most likely they don't want to do what we're currently asking them to do. And so, of course, we have developed algorithms and developed methodologies to be able to rescue as much data as it is possible. And that's exactly what we've been doing here. And so the good news is of those we were able to collect data, they all provided some degree of usable data. So, imagine like in the future where we'll plot, for example, graphs or figures where we represent each individual as an individual time points, you will probably see for most of everything 52 individuals for resting state and 49 for auditory evoke potential. The disclaimer here, again, just full transparency, is that, of course, data quality is overall very high, as just described to you. So most of everybody has greater than 85% usable data, meaning that 85% of the data they contributed, which for most of everybody was 5 minutes, was usable, which again is great. There's a little bit less usable data for the auditory task. Again, this is because or due to the reason that this comes after resting, and there were some less tolerability of the net at that point. But anyway, this is something we love to see. This is something we like to work with, and definitely again way better than what we usually see. So that was great. All right. So now let's go into the more like looking at the data and looking at what, individual participants to start realizing or to start like and trying to uncover some of these differences that we're seeing. So we have to go back to Anna's favorite figure, which is down here. Where again, if you remember I don't know, 5-10 minutes ago, I was describing to you that if we were to think about moving those squiggly lines to a different space, to a different realm, we do have the not squiggly lines anymore, but we have the distribution of power from the low to the high frequencies. And what we're actually we love to try to get an handle of or trying to understand is how these different frequencies distribute in the data for one specific in the EEG data for one specific participant. So here is an example of a participant that was completely from a different study. So not a KdVS kid. And so here I wanted to put this here, and I'm going to go over it in a second to try to describe a little bit to you what would like to see or what we think we see in more typically developing individuals. And so then relate this to some of the differences in 2 or 3 kids that we've seen, again, to really trying to get to a more hands-on approach of like what we usually tend to look at and what different quantitative information can be derived. So as I described, like on the x-axis of this graph, so this horizontal graph right here, what we like to show is the different frequency bands. So we move from like low frequency, here we usually start at 1 hertz up to like 50 hertz. So you can see, the 1, the 10, the 20, the 30, 40, and 50. I'm sure you might wondering why the hell number is getting all squished towards the right hand side of the graph. Don't blame me. This is how people show the EEG, and it's not the way. Is just basically the way people do it in the field. So this is called logarithmic. So basically you do have the lower frequencies much more like spread. So they occupy a larger portion on the x-axis. And then you do have these higher frequencies. So 10 and above more squished towards the right-hand side. And then on the vertical axis, so the y-axis, what you do have is the power. Again, this is how the field does it. So you do have lower power more towards the bottom, and I hope you can see my cursor, and higher powers more, which is distributed more towards the upper part of the graph. And so the thing I would like you to, for you to pay more attention here, or the most attention here, is to basic characteristics of the spectrum. And again, this is from one individual, 7 years old, male. And what we would like to predominantly see in this graph is that the frequencies or the power associated to the different frequencies tends to decrease in a sort of linear way. So if you can follow my cursor and imagine to draw like a line, from the low frequency to the high frequencies, you can see it kind of it goes down as a straight line. Of course, it's not a perfect line, and there's some bumps along the way, which I'm going to describe in a second. But this is what you will like to see. So straight line going from the low frequencies to the high frequencies. We also like to see this peak, which is somewhat around 10 hertz. This changes as a function of age, but it's usually between 6 and 10 hertz or 12 hertz, which is called the alpha peak. This is a very well documented part of the spectrum that we always would like to see. This is this is associated with typical development, is associated with presence of attention to stimuli and all of that. It's usually a marker of cognitive performance. And so these are the two main things that we usually like to see. So in the next few slides, in fact, next few clicks, I'm going to show you some examples of the data that we have collected over the summer and how that relates to this. Again, I acknowledge the fact that the way to present this could be done in different ways, and we don't usually, or it's not necessarily the best way to do this, in the sense that usually compare genetic kids or genetic participants to typically developing individuals. However, this is most likely the best way we do have to start characterizing differences. And then more in the next slides, we can go over how we may be able to look at differences, not just compared to typical individuals, typically developing individuals, but also within the condition itself. So this is one first example. Okay, this is red one now, is one first example of the participants that we have collected over the summer. And so what you can see, or at least I'm going to try to describe to you, is some of the differences. So the first thing you can see for sure, and this is an age match. So this is also a 7-year-old male that was collected over the summer. So what you can see here is that overall, there seems to be a higher amount of power. So you can see that this line, the red line right here, sits on top of the blue one for basically most of all of the different frequencies. So you can see here in a low frequency is sitting on top of the blue one, and the same is true for also the powers at the higher frequencies. There seems to be less of a difference in this area right here, which is the so-called beta band between the 20 and 30, which has been with differences have been associated with difficulties in language and expressive language. But here, for example, with this individual kid, doesn't seem to be too much difference. And you can see here then this, there seems to be more power here at the higher frequencies. But then I would say for most of the range of frequencies, you can still imagine to draw some sort of a line, some sort of a line here to, things are disappearing too much cursor movement. You can still think about to draw like a linear line up here, though there seems to be a little bit more power up here, and we'll go into the details of that. The other thing you might have noticed here is that despite the age is the same compared to the blue kid, this alpha peak seems to be positioned a little earlier, so at lower frequencies compared to the blue one. And what we know regarding to alpha is that is definitely an association with age. So the older you are, the higher the frequency or the central frequency or your alpha peak is. And so in a way, this would have been more, relatable or more close to what we would expect in a probably 4 or 5 years old if we were talking to a near typical developing kid. So this is, one example of one of the things we're looking at. Then here is a different example of a different kid. Again, age, in this case, I think it was a smidge older. than the 7 years old boy right here in blue. Again, our, let's call it reference. And if I haven't done such a horrible job at describing EEG so far, I think it would be pretty intuitive here to notice the fact that we're missing our big guy right here. So in this particular participant, we are actually not seeing any alpha peak at all. So this is, interesting in the sense that to some extent, or there's evidence of the fact that alpha peak definitely is, or the power associated to the alpha peak, meaning how peaky this peak is, how tall this is compared to the baseline, is different in different individuals. But the fact that we're seeing a complete absence of this alpha peak is actually pretty interesting. Again, there's associations between alpha peak and performance on cognitive task. There's in more typically developing kids, like lower alpha has been associated with less math readiness and like lower school performance. And in another paper, which I think it's out now, which was on MAP 13K, we were seeing that poor behavioral performance, which were evaluated using environment, were associated with less peakiness of the alpha peak in a more predictive fashion. This is to say that, again, alpha, and this is getting some attention with respect to clinical trials, definitely could be something that could be looked at and associated, again, with more behavioral outcomes. So that's, again, was another kit to show you how these, things we're looking at and things are starting to look a little promising. There you go. Then I think there's a third kit, which has, I think, a little bit of everything that we have discussed all combined in once. And I wanted to put this here to be some sort of like refresher or some sort of like summary of everything we've seen so far, and also to give a sense of the fact that the picture is complex in the sense that we would like to find a biomarker. I mean, that's, I think, the dreams, and that's what I think we'll all love to see, like a single biomarker which can tell us all about the brain that we can intervene on and change things. But a few things that you can see here. So, and again, age range was not exact, but comparable-ish. You can see no alpha peak at all. Like there's no alpha peak over here. Frequencies are higher only compared to like the let's say call reference, only in the more on the lower end of things. And then at some point around 10 or more, you can see that there's this very significant accumulation of higher frequencies, of power in the higher frequencies. So you can see the distance between the red one line and the blue line gets significantly higher at the higher frequencies. And the amount of data usable for these two individuals was comparable. So we're not looking at a participants that, for example, only contributed very few minutes because it was moving a lot, or the quality was very poor. So this to say that here we're seeing definitely a signature here. And this should not, I think, be too surprising in the sense that accumulation of power at the high frequencies definitely has been reported in individual with genetic conditions, specifically those at risk for autism, even in more in the general population. And then the third thing that I would like to highlight here is the fact that, again, imagine drawing a line here on the blue one, again, goes moving from the low frequency to the high frequencies as some sort of a line. What you can see here, definitely, this stops to be a straight line, around 20, 25, and then here it just kind of flatten out at towards the higher frequencies. Again, highlighting these differences in terms of higher power. But then to one of the things that we're particularly interested in, I keep talking to you about this imaginary line because this slope, so how steep this imaginary line looks like, has been related to excitatory to inhibitory ratio of the brain, which we know pings or trying to be an indirect measures of some of the inhibitory to excitatory synapses in the brain itself, which we know have been associated with developmental condition, and also implicitly some of the same circuits that some of the medication that some of the kids were actually, taking, or they're trying to targeting, specifically at those, at those ratio. And so that's something we're very excited to be taking a better look at, and we're interested in exploring that more. And I think that was the last example here. And I think we can skip
Perfect.
to this. Anna,
Yeah,
you
yeah,
tell me
yeah.
how much time do I
No,
guess
no, no. This is good. I think
okay.
sum it up.
Summer. Okay, perfect. Okay, yes, that's a great point. Yeah, I will be getting to your question in a second. So, summarize what we've seen so far. We demonstrated feasibility and reliability of collecting EEG data. Again, this was, let's say, aim zero for me for this, trying to see if we can work with this population and whether or not me torturing your, kids and young individuals was worth it and wasn't too much of, a burden. But I think, and I hope that was worked out very well, and definitely the data is telling us that story. We're starting to see differences in EEG pattern in KdVS kits compared to matched controls, and findings are actually pinging or looking at some of the same things that have been documented in other conditions, and definitely it's going into direction of thinking about promising biomarkers to be able, again, to get a start somewhere and see whether or not this can be upscaled and utilized. Next steps, things that, again, we have an opportunity to discuss. So we want to bring this comparison more to a statistical rigor in the term of like comparing this with neurotypical developing cohorts, and try the best as we can to age and sex match these individuals. And then another thing, looking at what we're discussing earlier. So we tend, again, often in science to have a reference group, but it's also true that in other condition that we actually have a couple of papers out. Again, the one I was describing to the MAP 13K and the PPP 2R5D. What we also did was a subgroup analysis within just KdVS cohort to see, for example, whether or not different mutation within the gene, different profiles that other people much more well versed in genetics might have identified are actually different, and not just compared to typical developing individuals, whether or not there could be autism, or maybe I think here is even more ADHD related. And then I think the last step, which feels like last final aim, would be starting to explore links between other domains that have been collected at the meeting, which I think is the most promising aspect of this. For sure, should look at the relationship between EEG biomarkers and then blood biomarker, or breath biomarker, or behavioral measures. And again, this is to say that we do torture you with a lot of questionnaire and a lot of everything, but we're really interested to see if we can link all these things together. To Alana's point, how repeatable is the EEG? Yes, it's a good question, and something that I can send you some references for. So people will be starting to look at internal and external validity, meaning that within the session, how are these measures stable? I did a little bit of this here, and definitely they're stable within the session. So like if you were to look at the first 1 minute versus the last 5 minutes, there's definitely there's replication of that. Outside of that, like multiple sessions. So for example, we're looking a little bit of that when we do have the opportunities for being able to look at longitudinal measures at different family meetings. As you might imagine, the confounding factor that happens there is age. Like our kids age, regardless of their genetic condition, they develop. And so if we were to look this, let's say day to day, there's certainly some stability. Year to year, stability is less, but stability is less probably most attributable to the age factor. That definitely is a big driving factor. And so I think you're prompting me to say, like, definitely getting as much as possible across the largest or broader age range is important, because we want to characterize their trajectory of development, which is typical for their specific genetic condition, and then see whether or not changes we're seeing are not masked by the effect of age.
Mm.
Because, otherwise it's easy to say, yes, there's a change, but is that change different just because typical developing kids change in at a different pace. But KdVS kids do change and do age. They just do it on their own pace and their own rhythm. And so we want to understand if that's not masking what we're saying.
Yeah, interesting.
And with that, I just want to thank you for listening to me. I talked probably too much, but it's very exciting. I'm very happy, everything that is coming out of this and all the support. And as I usually say, thanks for doing all the work and just allowing me to, take a peek at the data and do some silly jokes with the kids.
Perfect. Thank you, Nicolo. That was great. That's perfect. No, that's awesome. That's exactly what I wanted, for people to start seeing like the types of stuff that we might potentially get out of this. So, we had at our summit and at our webinars, we've had at least 3 or 4 different people tell us about the importance of biomarkers and drug development in rare diseases. And this is one of the classic examples of biomarker discovery in this type of developmental community. So thank you very much for your time. Okay. So, all right. So now I'd like, in the last 9 minutes, Nicolo, you're welcome to stay if you want, but we're going to switch to showing the community about how they add their electronic health records to Matrix. Okay, cool. So this is the next step. So since Nicolo has convinced all of you listening, watching, to join the natural history study who have not been part of it yet, we are just going to briefly walk you through one particular aspect of it. Elena has graciously offered to show her IT skills. Like I said, a live demo is probably worst decision that we've made in a while, but I think it's going to be great. Okay. And it's also super important. So Elena, let's make sure you can share your screen first. You should be able to. Beautiful. Okay, great. Okay, so actually, and while we're doing this, hey, Megan, would you mind putting in the chat for people the link to Matrix? Yes, cool. And you can even put the link that says not registered, where they can start from scratch, really from scratch. Okay, beautiful. Thank you. So Elena is showing you the online data collection portal that has all of the surveys, and in the future, all of assessments will be compiled here within your child, young adult, adults profile. And so this is called Matrix. And so right now, Elena, I guess I'm going to keep talking about you like in the third person while you're here, but so Elena is going to log in. This is everybody who's in the natural history study will be able to do exactly what she's doing right now. You log in, and this is the first step. This is perfect. So some of you might have multiple kids on your dashboard. So right now, Maribel is the only one on her dashboard, but some of you who might have had your kids donate a blood sample, etc., you might see multiple children and multiple caregiver or multiple offspring here. So we're going to click on the one that we want to pull in the electronic health records for here. Before I do that, you can see that there is an abundance of surveys. Elena, see if you can go on that left-hand side where it says 8. Yeah, click on that and see if it does something show.
Was my completed or what?
Yeah, we can go over to the ones that are completed. So there are a couple surveys here, and Elena is a really beautiful example of completing the ones that I really want her to do. So well done. You get a sticker.
Thank you.
So you will see many, 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 many surveys on the portal. And the ones that we are really pushing for are the ones that we think are actually going to be the ones that are most helpful and informative when we have a clinical trial. And those will be the one that's called Vineland, which is a lengthy survey. You can see Elena sort of hovering over it right now. The other one is an epilepsy survey. It starts with PELHS. Yep, that is an epilepsy. That is much shorter and should only take, all of these are online too. So you can start them, save them, etc. whenever you have the time to do so. And then the last one, which I think is probably one of the most important for the KdVS community, is the survey on communication, which Nicolo actually is probably very familiar with, which is the ORCA. Yep, right there. Perfect. This is also pretty short. It takes somewhere between 10 to 15 minutes. Also online, and you fill it out on behalf of your kids' communication abilities. A lot of these we will ask you to fill out annually, no more frequently than that. But the real reason is we want to see how these communication abilities or other developmental abilities change over time. This is what the real foundation of a natural history study is seeing how do things change with age. Okay, so now you can sort of see the names and what it looks like to find the specific surveys that we want completed annually. Elena, if you can go, and I think this is right, this is kind of where I'm winging it. If you go over on the left-hand side where it says health info. All right, perfect. If you go to where it says manage EHR connections, perfect. There you go. Okay. So this is where you can enable Matrix to pull in your electronic health records from the different medical centers or clinics that you have visited. And now you're probably thinking, well, okay, she's asking me to do something else, more work, more surveys. Not exactly. This should be pretty easy. And one of the reasons that this is really important, and I hope will actually alleviate the need to fill out some of our surveys, is because there's really valuable information from the electronic health records that we can use often in the place of surveys. So yes, this is something else, but I think this ultimately might reduce the amount of surveys that we ask you to complete all the time. Okay, so can you scroll down a smidge? Yeah, perfect. Okay, so if you go to import health records. Perfect. Perfect. Okay, and you have to say yes. Yeah, it uses this sort of like third party to fetch some of these things. Scroll down. Okay. Please enter. Perfect. So now you type in like, yeah.
Like the hospital?
Yeah, like any, yeah, healthcare system, clinic. Sure. Perfect. And it's actually not gonna, it takes a while to like find, in this example, Marybelle and bring it back. So like a bunch of medical records aren't gonna pop up on the screen right now. If you type in, let's see, sometimes you don't even have to put in, let me look it up.
Do I put in less stuff? Is it like my
The thing
bogging
that
down
you
a search?
need is actually see if you can do it just with a zip code. Click
Yeah,
on
I think
the
you need to put the zip code in because it's
I can find it. I can look it up right now.
and the
Yeah, I
location.
don't like
Just type
the
in
city.
nationwide and then type in the zip.
Here we go. I have so I just found Google told me 700 Children's Drive. So let's try that.
That I could have told you, but I don't know the zip.
Oh, it's 43205. Booyah. Yeah, goody. All right.
So do I choose the main one or do I do like
Yeah,
more all
choose
of
the
them?
main one. Because I think it will pull it in from all of those smaller, like regional ones
Yeah.
or departments. So click next. And then you have to say, yes, do you let us go and get your child's medical records?
Oh, so I am
now,
it's okay. I mean, I don't mind logging in. Do you want me to log in?
yeah. I don't actually think it's going to show anything.
I'm kind of an open book, but if this is going to be on YouTube, maybe I don't want to.
So stop sharing your screen just for a second.
Okay.
I don't think it does it. I think it just like has you sign in to make sure you are who you are so that it will link it. But you're right. Let's make sure we don't show everybody like your social security number or something like that.
Yeah, like I vaguely feel like I've done this before. Would we have done this somewhere else before?
Maybe.
Yes, we would have done it for Citizens.
This is how Citizen works too.
Okay.
And the only reason that we're trying to do it through Matrix is so that everything is in one place. So we don't have to have different things.
All right, let me share my screen again.
We'll make sure that we don't know all of your.
So it looks like it just says granting access will
Yay!
give them
Oh,
access
perfect.
to
Yeah.
data.
Yep. So then click on Maribel. Yep, and click continue. And then it says we are not gonna sell your data, etc. And click continue. And then it says like what types of things do you want to share? Do you want to share like things about allergies, like visit summaries, etc. And for the most part, I would just unless there's anything specifically you don't want shared, I would leave everything. So the other last thing you'll note, scroll all the way down. So you can see the very last thing right here says, how long would you like green light to have access to your information? So you can do it for an hour, a day, a week, a month, or 3 months. So 3 months is the longest that you actually are allowed to share. So I tell people to click 3 months, but then just know that whenever and there you go, and that's it. So all you do is that it takes like somewhere between a couple of days and a week for things to start showing up in your Matrix account. And sometimes there's a couple additional steps that you need to go through to sort of, some hospitals have different levels of paperwork, etc.
And I did just get a text from my hospital saying a new app has been linked to your MyChart account.
Yay,
so.
Cool. Yep. Awesome. Perfect. Yeah. I would say that happens more often than not from the hospital side, which is good. So that is how you do that. So this is a really cool additional aspect that we can link to our natural history study. And I think it will be super helpful. Go ahead.
So you would want, so we've been to Mayo Clinic, so you would want Mayo Clinic in there. Do you want things like the pediatrician's office too, or is it mostly you're going for, is it like our local hospital system because we go to the ER there? I mean, does it everything like that?
So to me, obviously as many things as you're willing to put in there, but if you were to devote a set amount of time to this, it would be to pull in the office that has the most medical records, like the ones that have the most repeated visits, not like one 2-day emergency room visit, as opposed to a pediatrician's notes that have followed Maribel for 5-10 years, etc. Those would be way more valuable.
Right.
Yeah. Cool.
All right.
Okay. Okay, so you can stop sharing your screen in case something secret or very personal pops up, but we avoided disaster. That's great. Okay. So if anybody has any questions about this, feel free to email me or Megan or Ashley. And does anybody have any questions? There's still quite a few people on. This is awesome.
I just had a couple of quick announcements. So we did have a question about participating in Citizen versus adding this information to the Matrix. So we would ask, if you have time, do both. They're both very valuable, and the extraction from Citizen is a little different than Matrix and the information that we have there. So if folks are signing up for Citizen, please do. If you haven't yet, we ask that you would maybe do the Matrix first, and then if you have time to do Citizen, also do that. Additionally, we have some upcoming biosample collection dates. So there will be a collection in San Antonio and Orlando. So if anybody is interested in donating a biological sample at one of those locations this year in March or in April, feel free to email me. There will also be some other locations throughout the year that we'll keep following up. But if one of those locations are near you or you're going on vacation, please reach out, and we would love to or coordinate getting a sample collected. Additionally, if you have any upcoming clinical procedures that you know of for your child, please feel free to reach out to Ashley and Anna and I to coordinate that if there's any biological specimens that could be collected as a result of that. Also, I've been bugging folks about your surveys. Please, one last reminder to get those done as soon as possible. We would love to be able to include all of the information from last year and make sure that everybody's up to date from their 2025 surveys before the 2026 are released to you, because we'll ask that you keep doing them manually for some of those surveys. So thanks everybody for your time and attention.
Perfect. Wonderful. I know that was a lot, but thank you guys for hanging in there. We'll post this online, and please get a hold of any of us if you have any questions. Thank you again, Nicolo.
Yes, thank you,
Thank
everybody.
you
We
all.
really
Yeah.
appreciate all
Really
your help on
appreciate
this.
it.
I know it's very tedious, but we appreciate Nicolo for all his work and Anna and Megan just to keep pushing our science forward. And we couldn't do it obviously without all the families and all the family support because we know how much time it takes. Trust us. So please reach out if you have any questions. We're always here, and we look forward to seeing you again soon. Thanks, everybody. Have a good
Bye.
day.
So we're going to touch on, believe it or not, what she's going to show today is just like the tip of the iceberg for what we have found and can find and sort of glean from the work that we collected while we were at the summit. How to get involved in the natural history study and all of the work that the foundation is doing, and then future webinars who will present more aspects of the natural history study.
What about coffee?
Okay, so I think this is a slide that I quite literally show probably every single time I talk about natural history studies or some aspect of the drug development pipeline for rare genetic neurodevelopmental disorders. So I won't go into every single part of this in great detail, but you can appreciate if you can see my cursor. Megan, can you see my mouse cursor? Okay, cool, thank you. If you can look on the left-hand side of this slide, you see you start in the drug development process by identifying the gene that causes sort of the clinical symptoms that you're observing in a population. And then the next part is you have to develop both rodent, or various in vivo or living animal models, as well as cell models of the disorder. Because as you can imagine, you can't really test compounds and test things in the brain of humans. And so you have to come up with basic research models to really interrogate and investigate the pathogenic consequence of these genetic mutations. And then one of the other really critical parts of the drug development process is natural history data collection. Now, what is natural history for a disorder? And basically what that is it is observational studies across ages or the timeline of a particular disorder to really capture the symptoms or the other manifestations of the disorder that are present at particular time points across the progression or the duration of the disease. Now, one of the reasons that this is really, really important, I'll name two, but there are definitely more than this. One is that when you get towards clinical trials for a particular disorder, it is really important to find symptoms that are relevant for the age that are going to be eligible for that clinical trial. Meaning that if you have a clinical trial that focuses on infants or toddlers and behavioral symptoms aren't really a problem at that age for that particular disorder, it's not appropriate or not smart to make behavioral changes and symptoms the main readout for whether your clinical trial succeeds or fails. And then the other really amazing thing about a natural history study is that if you know the symptoms and how the disease progresses with time or changes with time, then at a certain point, you don't need placebo study arms when you have a clinical intervention for that particular disorder. And we see this happening for other rare diseases that have a really robust natural history study. So this is really the ideal. And this requires longitudinal data collection for several years amongst the broadest clinical presentation for a particular disorder. Okay, so then the only other part of this paradigm or the schematic that I'll talk about right now is if you move a little bit further to the right, you see that one other really critical component of drug development is the identification of biomarkers for a particular disorder. Now, biomarkers, as the image suggests, is not just blood, vials of blood, but what they are objective measures that you can measure in the blood, for example, or other biofluids, or even physiologic measures like things like how your brain responds to certain stimuli. And those types of biomarkers are things that you guys are probably very familiar with, like electroencephalograms or EEGs. These things are really important in addition to natural history study, because they are objective indicators of whether a certain treatment or intervention is actually being effective or not, or improving or not, or worsening, for example. And then as you get all the way to the right-hand side, you see that you have patient-centered outcome measures, so outcome measures that are clinically meaningful to the particular population, and then clinical trials and FDA-approved medications for Koolen-de syndrome. Okay, so one of the biggest challenges for trying to figure out what aspects of disease to investigate really comes from the community. So this is one of the main reasons why a natural history study is important, and also studies like a disease concept model, which Koolen-de Syndrome Foundation is doing right now, is because it provides, these types of studies provide an unbiased view of what types of symptoms are being reported in the Koolen-de community, is in children of a variety of different ages and a variety of different genetic mutations, as well as a variety of different clinical presentations. So we know that for individuals who have neurodevelopmental disorders, and everyone listening on this call knows this very well, in addition, is that even though it is a neurodevelopmental disorder, other organ systems besides the central nervous system are very heavily impacted. So in addition to various clinical issues associated with impairments in the nervous system, as many of you know, there are a variety of different congenital cardiovascular abnormalities that are very commonly observed in KdVS. Musculoskeletal problems, lots of orthopedic issues have been reported in KdVS. GI, endocrine, immune systems, recurrent infections, immune system, and the role of cancer in the immune system has been something that has more recently been studied and is currently being investigated by Dr. Koolen and Dr. DeFries. Urinary issues, issues with the skin, as well as issues with the respiratory system. So because a study like this really hasn't formally been done in a structured way with particular outcome measures or assessments being completed, we really wanted to know from the KdVS community, especially for families and caregivers, to tell us what are the most burdensome symptoms in your child, toddler, young adult with Koolen-de syndrome. So we actually did an online survey at our 2023 summit, where it had a variety of different questions about the caregiver, questions about symptoms in the KdVS individual, but ultimately the most important question was, it asked caregivers, if you had a pill that could treat a symptom, so the most burdensome, most impactful symptom, what would it treat? And so if you can look at this figure on the right-hand side here, again, we had 100 caregivers complete this survey. You can see on the x-axis here, we have responses categorized by the KdVS individual's age. So individuals 0 to 5, 6 to 12, 13 to 21, and over 21. And then the y-axis right here is the percent of respondents within that category. You can see that for individuals who are between 0 and 12, the really most top symptom priority to be improved is communication skills, and then neurological. Now, interestingly, when you look at individuals who are older, communication isn't even a percentage of the response for caregivers. In fact, cognition and improvements in cognition are really the top priority. And then you also see sort of behavioral and emotional issues that seem to be a higher priority in 13-year-olds and older in KdVS. So this really gives us an idea of what types of symptoms that we really need to be focusing on, what types of surveys to capture symptom severity, to really make sure that we include in the natural history study assessments. So now I'm going to walk through, these are the types of surveys that we have on our KdVS data collection platform. It's called the Matrix, in case you have heard people throwing that term around. There are a wide battery of assessments on the platform, and you can see sort of the reason for that is because we're not quite sure which symptoms are going to be the most prevalent in which types of KdVS populations. So we have the developmental history, which asks about all of these different organ or system issues. We have the a couple surveys of global neurodevelopment, so the Vineland Adaptive Behavior Scale, which I'm sure most of you have taken and are very familiar with. Although the survey, the title says adaptive behavior, this has been used canonically as a general indicator for neurodevelopmental status for many, many years. And then we also have the CDC milestone survey. So at what age does your child hit certain developmental milestones as a way to determine if they are hitting milestones age appropriately or delayed. Epilepsy surveys, diet, communication surveys. This is a really important one for the KdVS population, as we just showed you, that measuring changes in communication skills were a top priority for the community. Behavioral assays that will capture some of these maladaptive behaviors that individuals have developed and other neuropsychiatric issues, and sleep surveys. So we have Megan, myself, Ashley, and others on the research committee at the foundation have designed a sort of multi-layered natural history study that includes online assessments that can be completed at your own time on that Matrix portal, in-person assessments for those who are able to make our biannual KdVS patient summits, and then a handful of remote assessments as well. Hold on, there's something that just put something in the chat. Oh, thank you. Okay, does someone have a question? Or I don't think so. I think Mary Beth was just talking. Okay. So the online surveys that we are really encouraging families to prioritize. I know there are many more from this, but we will work with you and Megan to really, hopefully really clearly point out the ones that we really, really would love for you to complete. And those are the health and development surveys to get a really thorough snapshot of those other organ systems that are impacted during development in your child or young adult. The Vineland, the aberrant behavior checklist, as well as that communication survey, the ORCA for short. One thing to reiterate is that many of these, so not just these online surveys, but many of the in-person and remote assessments should be completed annually. And we know that's not, surveys are no one's favorite thing to complete, but as I said towards the beginning, understanding how symptoms change with age is a really, really critical part of establishing a natural history study. How do things change with age? And so because of that, we ask for many of these surveys to complete it on an annual basis. And we will help send out reminders to encourage you guys to complete those select surveys. Okay, So here is a really amazing snapshot for the types of research assessments that we completed at the summit. I'm going to say we, but really this work was almost entirely done by Megan, who was running around probably for 24 hours a day for the entirety of the summit to make sure that we really capitalized off of everybody at the KdVS community while we were there and had a lot of research opportunities available to us. So the current enrollment for our natural history study is 95 individuals. 60 of those are individuals with KdVS. 35 are either parents or siblings. And you might be asking, why is it important to have people who are not affected with KdVS involved in natural history study? And I'm happy to go into that a little bit later. Among these 70, or sorry, that number is not 70, that number is 60. Among the individuals with KdVS that we have enrolled thus far, we have 54 completed the health and development survey, 40 completed the aberrant behavior checklist, 35 have completed the ORCA, and 25 have completed the Vineland. We also had 39 patients have a really comprehensive neuropsychological battery completed. And this was done with the collaboration of a couple investigators at UCSF, including Summer Bishop and her team. They completed the Wechsler series on 39 patients, and we will have more data to show at a future webinar on some of the findings from this. We also collaborated with Nicolo Pini out of Columbia University, who completed 52 EEGs on participants while at the summit. He will be joining at a future webinar as well to show some of the interesting preliminary findings that he has found from patients from this work. We also collected 39 patient samples and 3 controls for the biorepository at the summit as well. This was really incredible because a large number of these were actually participants that donated in 2023 when we had our patient summit in Orlando. So we already are set up really nicely to have longitudinal blood collections to look for blood-based biomarkers in KdVS. We have several investigators who are actually actively looking at and using these samples already. The other thing that we collected while at the summit were nitric oxide samples. So many of you might remember me or somebody else sticking a probe at the tip of your nose to measure nasal nitric oxide production. The reason for that is not just because we want to give you PTSD from COVID testing. It was because we think that nitric oxide, nasal nitric oxide production might be a biomarker for some of the molecular impairments that are occurring as a result of CANSL1 haploinsufficiency. So this is another potential biomarker assay. And then so this last thing that we have completed thus far, this is one of the remote assessments. This is in collaboration with Ken Myers and Emily Batone at McGill University. And they have drafted a clinical global impression scale for KdVS. And they are piloting out this program. They have already enrolled and collected data from 20 patients. They are looking at that right now. We will have them present some of their really cool preliminary findings from this study at a future webinar as well. Okay. My throat is dry from talking the whole time. Okay, Megan, is this where you take over?
This is where
amazing. Okay, so Megan, so I just talked and explained everything, but Megan's actually going to show you some of the cool data that we've collected from you guys already. Okay, Megan, I'll mute myself.
Awesome. Thanks so much, everybody, for joining us today. I also want to reiterate how grateful we are to our families for all that you've done to participate in this study. We understand that this takes a lot of time. You had to take out time away from enjoying the activities at the summit. That requires a lot of sacrifice, and we really appreciate that. I know that like Hannah said, I was running around. I met many of you there and was very excited to interact with everybody and meet your kiddos. It was a great experience. And so we've collected so much from that. And now we're starting to do the initial data analysis. So this is all preliminary findings. And as Anna said, this doesn't even scratch the surface of what we've collected so far. The amount of buy-in from this community to participate in the online surveys is unparalleled. I've never seen another group of people so motivated to answer questions about your kids and to be open to research and want to participate. So we greatly appreciate that. And I also put the link in the chat if there's anybody joining us who hasn't yet signed up for the study and is interested in signing up. So you can click that link to go to Matrix. And if you have any additional questions, I will help you with that as well. Just going over the health and development survey here. So when we initially onboard new people into the Matrix, one of the first surveys that you're going to complete is the health and development survey. And so this survey essentially asks a lot of different questions about whether or not you have experienced some changes related to issues with labor and delivery, for example. So that's what we see in this first column. Anna, do you see a bunch of check boxes? Why are there so many checks?
I don't know. That's a fun thing. I do see check boxes, but those don't mean anything, do they?
Nope. I don't know where they came from, but now we have lots of checks. But
okay.
Oh, you're
sorry. I don't know what happened. What? It must have. Hold on. I was trying to fix your Okay, hold on. Whoop. Oh, there. Sorry. Just make sure you're awake.
Perfect. Thanks, everybody. Okay, so with that, so some of the questions it asks, for example, if there's changes in labor and delivery, if you had any issues with growth. So as your child is aging, do you see that there's any changes in growth, whether that be slower, faster? Those are some of the things that are captured there. If you have any issues with the endocrine system, so that could be things like diabetes or just changes in hormone levels that you've noticed, brain and nervous system. So any changes related to maybe something you might have seen in an EEG or an MRI, behavioral and psychological changes. So those are, some of the things we've already captured where we talked a little bit about mood and behavior. So those are also some of the questions reflected there, changes in the heart and blood vessels, lungs and breathing and immune system. And as we can see here that it's about 50-50 for a lot of the different systems. So whether or not there were changes experienced in pregnancy, so that could have been maybe a premature birth or any kind of complication with mom during the delivery. So we see that roughly about half said yes and half said no.
So blue is yes, right?
Blue is yes, orange is no, and green is unsure. So there's three options for this survey. And again, there's more features besides just these different systems that are listed here. But for growth, we can see that many patients do experience changes in growth, whether that be slow growth or precocious growth. Unfortunately, this survey doesn't really break that down too much, but we have other surveys of development that we're going to look into a little more to see what those changes look like. And then for the endocrine system, we can see not many people have any issues with the endocrine system. So that's one area that's less affected in KdVS, whereas brain and nervous system, the vast majority of folks did say that they did have changes in the brain and nervous system. For behavior and psychology, we see that it's roughly about half there. With a little less said no, with a majority saying yes. Same for heart and blood vessels, roughly about half. Lungs and breathing, still majority no, but a large proportion of individuals did identify that there are changes in the respiratory system. And then for the immune system, this is one area that other researchers are actively looking into for KdVS. So we can see here that there's a proportion that said yes and some that said no. So I think that there's a lot of underlying information that we can garner from that. Some of the other systems that are captured within this survey include things like changes with cancer, vision, ear, nose, and throat, which that was a big one. I didn't include it in this chart because it was starting to get busy, but ear, nose, and throat, that was a super common one. We had over 28 respondents say that that was an issue that their child experienced. Changes in skin, muscles, things of that nature. So lots of different information is captured there. For muscles, that was another one that was pretty large. About 31 individuals said that that was a challenge that they faced. So I think from the health and development survey, we can get a better picture of what some of these systems are going to be priorities for families, like from that initial survey that Anna was talking about earlier. Anna, if you can advance us. Perfect. So now we'll talk a little bit about the Vineland Adaptive Behavior Scale. So these are standardized assessment tools. Anna briefly introduced those. So essentially they're measuring developmental delays. They're often used in autism spectrum disorder, intellectual disability, as well as other developmental and psychological conditions. So they're used for a variety of different things. And there are some different scores that we get from the Vineland. So for those of you that have participated in the Vineland so far, thank you so much. It is a very time-consuming scale, and we understand that and recognize that sacrifice that you're making to go through and answer those questions. So thank you again for the families that have completed it so far. And for those of you that are already enrolled and haven't yet completed it, I encourage you to complete the Vineland because we think this is going to reveal a lot of interesting information, which it already has. So here we can see that we have the communication standard score. So the Vineland has some domain scores, which are basically domains of adaptive behavior. So communication can be broken down into different things, such as receptive communication, expressive, written communication, daily living skills. So that's another domain. So that can be personal. So, things like grooming, things like that. Domestic. So being able to do chores around the house, or, community daily living skills as well. And so some of those are reflected there. And then we also have a socialization standard score. So this is looking at interpersonal relationships, how your child plays with other people, how they spend their leisure time, and any coping skills are also captured in that. And then the composite score, the adaptive behavior composite score, this is kind of an overall score that summarizes the individual's level of adaptive functioning. And so the standard score for all of these, the mean is set around 100. And we can see here that for the average score for patients with KdVS, so this only included, I think it was 25 so far that have completed the Vineland, but we can see that the average score for communication is around 60 for that domain, so 60.72. So that reflects that patients are having some challenges with language. For daily living skills, that was around 63.96. So that's reflecting that there are some challenges related to daily living. And then for socialization, we can see that there are challenges with social behaviors, that's around 65. And for the adaptive behavior overall, it is a little bit higher, but it's still reflecting that it is below that mean of 100. So essentially what this is telling us is that there might be some mild delays and there are challenges in different areas for patients with KdVS. And so this is really valuable information for us because the Vineland is often used in clinical trials to see if there are improvements in these measures with different treatments. So the better idea we can get of a baseline across patients and then also be able to compare that over time, the more helpful it is for us at moving forward. Perfect. So now I'll spend a little bit of time to talk about the ORCA. So this is a really interesting new developing score that is being used. It was developed at Duke. And so the initial cohort was, I think it was roughly 250 caregivers that participated in the reference cohort. And so there are different concepts that are covered in this communication scale. So Anna talked about how a lot of our families said that communication is their top priority. So there are different areas of communication that we want to assess and to better understand what the baseline level is and if there's ways that we can improve some of the subtleties of that. So if we think about expressive communication, this is when an individual is seeking attention or directing attention. So this could be in the form of a conversation, saying, hey, look at me, or trying to direct someone to direct attention to something else. And then this also can be with object direction. So, refusing to eat a type of food or asking for a certain type of food or a toy or something of that nature. Requesting an object out of view. So that would be another example where if something's in another room and they're asking for that item, an iPad, for example. Asking questions, that's another form of expressive communication. And then kind of like narrative storytelling about the past. So being able to reflect and recall on that, that's another form of expressive communication. So these are some of the different areas that the ORCA is assessing. It also assesses receptive communication. So that's being able to respond to someone's name, understanding some of the characteristics of someone's mood. So if mom and dad aren't happy with somebody, that would be, trying to pick up on those social cues. And then understanding, making choices, following directions, things like that. That's more receptive communication. Whereas pragmatic communication is being able to comfort other people, greeting people, and playing games with other people. So those are kind of the concepts that are built into the ORCA. And I'll talk a little bit about the scores that we got. if you want to advance, Anna, thank you. So with the orca, really interestingly, the mean of the orca is built around 50. So we can see here that patients with KdVS are scoring above average in pretty much all of these areas, which is really interesting. So we can see that for overall, the overall orca score is elevated. So we see that at 67.48. I believe the standard deviation, the range rather for the orca scores go for overall anywhere from 25 to 83.8. These are built in what's called a T-score. So that's just how these are calibrated. And so we can see that patients with KdVS, they're scoring above the mean of 50, but slightly below the max. And so this is really interesting for us also with the expressive language. So some of those different features we were just talking about, we can see that one, the range is anywhere from 34.6 to 75.9. And we can see here that patients with KdVS also still around the 60s. So we have 66.71, still above the average there. And that is also true for receptive and pragmatic communication. So I think that this scale is going to be really interesting for us to get some more granular data from patients with KdVS to be able to understand how we can use this information and how patients are communicating. Because I feel like a lot of families observe this, that your kids are very social and they want to interact with other people. And I got to see that firsthand at the summit, which was so exciting and encouraging to meet with all of them and listen to them and see them play and interact with other people. So I think that's one of the benefits of this scale is it really kind of helps us compare to other neurodevelopmental groups as well, because the orca is being piloted across several neurodevelopmental disorders, and we're trying to get an understanding of how that scale compares across different groups. And so for us, we might be, for KdVS, we might be on the higher end of where things are for the orca, which is really interesting. And really the importance of this scale also helps us to prevent bottoming out. Whereas on a lot of other scales for rare neurodevelopmental disorders, a lot of patients, they end up being towards the lower end of the score, and you don't really get an understanding of what people are able to do. Whereas the orca is a little more in depth, where we can kind of understand those interactions a little better from social communication. So that's what we've learned so far. Anna, if you want to advance. So with that being said, I just wanted to talk a little bit about our community and where we're located and how we're growing, and how a lot of those numbers that we were talking about at the beginning, where we had 60 patients that are currently enrolled in the natural history study, they are not yet reflected in what we have here. So this is our patient registry community information. So you can see we have lots of families located all over the US, with some of these central areas where we know that there are lots of academic medical centers and lots of resources for families, where we have higher populations of individuals living. So it's pretty amazing to be able to visualize that we are covering the vast majority of the US and all around the world. So Anna, if you want to advance, and I'll talk a little bit about this. So you can see here that we have, over 276 families in the US. We have 22 families in Canada, big centers in Australia, Europe, Brazil. So we have lots of people all over in every continent except Antarctica. So I think with that being said, there's lots of opportunities for families to engage and to participate in the natural history study moving forward. Even if you're not located in the US and don't think that you would be able to participate in some of the in-person assessments and things like that, we encourage families that are located elsewhere to participate. It's a great opportunity for us to learn about the disorder from your family's perspective, where you're located, what your health system's like, and that can help us with deciding clinical trial sites moving forward. So we need to know where our community is and be able to refine the natural history study data that we have to be able to meet your needs as well. So we definitely encourage everybody abroad to participate. And we, it's amazing the way that this community has grown. I admire all of the hard work of the foundation for what they've developed with this patient registry. And we hope to only grow that with the natural history study and potentially be able to match those numbers and have people enrolled in all the different aspects of the study that they can participate in, because your information is really valuable, not only to researchers, but also to biotech and pharma companies who are interested in pursuing treatments, developing treatments for KdVS. And so that's what we hope to bring to you through all of this work. And if you would like to sign up, please feel free to email me. Many families have, oh no, did it get blocked? So if you have already signed up, I do ask that you would complete the surveys. So there are lots of different surveys that we talked about today. Those would be in your patient portal if you've already developed one. If you haven't, feel free to email me. We can work together. I know a lot of families, this platform unfortunately is a little bit tricky, and so signing up can be a little frustrating for families. I am so grateful to all of the folks that met with me multiple times because we had technical difficulties and it wouldn't work out. So I really want to reiterate that if you have any challenges or just have questions and want to know more, feel free to reach out to me. I'd be happy to assist you. We can set up a quick Zoom call and go through the informed consent process together, make sure we get all of your questions answered. And again, for those who have already signed up, please do complete your surveys and participate, because the more data that we have, the better, the more that we can understand about KdVS.
Okay. Yeah, I think this just reiterates. I think there's a couple of things based upon the questions that we've had in the chat, which I will just say. Yes, there are lots of surveys. No, you are not limited to participation for people in the United States. Anyone globally can sign up and complete the online research assessments that we just described. And I think those in the long term, if they are completed annually, will end up being the most helpful and informative in terms of establishing which the bulk of the natural history study, as well as establishing which outcome measures and symptoms we'll pick for clinical trials. So please, even if you live outside the US, please consider participating in this study. And the other really important thing is that Matrix, this data collection platform that we use, is in a variety of different languages. It's in Spanish, and Italian, German, Russian, maybe even Czech, Polish, French. I mean, so you should be able to read, and most surveys will be translated as well. If you have any questions about participating, you are welcome to contact Megan, whose email was on the slide before, or Ashley, who's the president of the foundation, or myself. Okay, so Megan just presented just a tiny touch of what we have collected from our natural history data. So our future webinars, which I think we'll schedule, we're going to try and do them monthly again. We will have Dr. Pini. He is the one who collected the EEGs. We will have him present next. And then hopefully right before the end of the year, we will have Dr. Baton and possibly Dr. Myers present some of their initial findings on developing the clinical global impression scale for KdVS. Okay, so that's my email address again. And okay, that is all that we wanted to show everyone today. So nobody asked, well, one person had a question in the chat, which I answered, but please, if you have questions, concerns, positive feedback, negative feedback, etc., things to improve, things to ask, etc., please feel free to ask them now. I'm going to stop sharing my screen so I can see everybody. Don't see any. Hold on, let me look at the chat. Okay.
I did just want to say there's so many folks on this call that I have spoken to, and I just really want to thank you again. This is a lot of work, and we recognize that and know that, and it's amazing in how short a time that we have accomplished what we've accomplished together. I know that there were so many tired folks after neuropsych and EEGs and donating blood at the summit that and coming back and completing these surveys at home, like, we recognize the effort that you've put in and are so appreciative and can't wait to see what else we're going to learn. So like Anna said, this is just scratching the surface, so we have so much more to come. So thank you again, everyone.
Hey.
I was gonna ask something or just comment.
Yeah.
This is Ann Sandberg, Joe's mom.
Yay. Hi, Anne.
He misses you. He misses you, Megan. We look at the picture that we took all the time. Anyways, but so yeah, someone commented there's a lot of surveys. Holy moly, there's a lot. But I want to just comment. So like, Joe's also part of the Spark for autism studies trial and collection data and all that stuff. And it's tough because like it's almost identical the amount of surveys I'm doing, and I'm having to fill them out twice. Like
So, are you filling out
I'm like,
surveys
is there
for?
any way that this could be like transferred or like so
Yes. So what platform are you completing survey? Like what are the surveys that you are completing that you've already done on a different platform? And what was that platform?
so I don't know, it's Spark is somehow connected to the Simons Searchlight, I
Okay.
think.
Okay, so that's fantastic. So one thing that we should reiterate is that if you have completed surveys on RareX or Simon's Searchlight, we can share information with each other as long as you enter Joe's CRID or
Oh, okay.
CRID
When
into your RareX or Simon's account. In which case, we can ask them for that information. We have a data sharing agreement exactly for the purpose that you just brought up, is like people being annoyed at filling out the same stuff over and over again. And the same is true for us. If you've completed a survey for Megan and Simon's is asking you for it, or RareX is asking you for it now, let her know. And then we can share it with a different platform. The other really big thing to keep in mind is that as more researchers, clinical researchers, enter the KdVS space, if any of them ask for the same assessments, if you log into your Matrix account, you should be able to download and export the vast majority of the assessments that you complete, so you don't have to repeat it again.
Oh,
Sense?
okay.
Yep.
Okay,
So,
yeah. So I think when we started with Spark, he didn't have a CRID, so maybe that's something I have to kind of go back and look into
yeah,
entering.
it is not intuitive for where it is. Like there's a little bit of digging. So we might have to set up a Zoom one-on-one with you to figure out where it is, because it's sort of like you have to click and then click again and find another box and enter it. So it's not intuitive.
Okay.
But I'm happy to help you because I don't want you to have to fill out the same thing multiple times. I hear that.
Yeah, I mean, I'm accumulating all these little Amazon cards, or credit because of all of this. And I'm like, no, I'd rather just not have to do it. So, okay, I'll reach out. Thanks.
Perfect. Okay, and Jan said they didn't make the summit. My child is 25. Perfect. Yes, we really need adults to participate as well. There's considerably less known about adults with KdVS. So your participation is particularly important. All right, cool. Okay, well, if there are no other questions, okay. Thank you all for being here. This was great. I'm so impressed with this turnout. Thank you so much. And next time we'll have even more data to show. And I hope it's helpful. All right.